So, number one says that g of x equals 5/8 to the x power. Okay. So, number one. 5/8 to the x power. Hopefully, you remember that when we graphed these exponential functions in the past, we used this table, right, of x and y being, those lesser numbers, -2, -1, 0, 1, and 2, right? So we use these lesser numbers because they're just easier to work with almost always. So by hand, guys, I'm going to go ahead and plug in each of these numbers, starting out with -2. So remember, g of -2 is going to be 5/8 to the -2nd power. And you can't really do anything with that till you make the exponent positive, so flip it. Flip the 5/8, that makes the exponent turn positive, right? Then 8/5 times 8/5 is my next step, which is 8 times 8 is 64, 5 times 5 is 25. 64/25 is all good, but like I don't really know how to graph that without thinking of it as a decimal or a fraction. Let's see what 64 divided by 25 is. It's 2.56, so that'll be a little easier to graph if you think of it as 2.56. Now I'm going to plug in -1. G of -1 is 5/8 to the -1st power. Well, again, you got to flip the fraction to make the exponent turn positive. 8/5 to the 1st power is 8/5, and 8/5 is exactly 1.6. So if you think of it as 1.6, it becomes much more graphable than 8/5. Next, I have, this one will be easy, g of 0, right? Because anything to the 0 power is 1. So 5/8 to the 0 power is 1. Now I'm going to plug in a +1. G of 1 equals 5/8 to the 1st power. Well, 5/8 to the 1st power is simply 5/8, right? Anything to the 1st power won't change. I know 5/8 is a little more than half, right? And it technically is 0.625 if you want to make it a decimal. One more thing to plug in here, guys, it's g of 2. So 5/8 to the 2nd power, aka 5/8 times 5/8, right? 5/8 squared. And that would leave me with 5 times 5 is 25, 8 times 8 is 64, 25/64ths, which is less than half. Half of 64 is 32. This is going to be about 0.39 approximately. So you see, plugging these numbers in by hand is a little tedious, and you can use Desmos to help you out, but it's pretty important also that you're able to do it. That way you don't have to rely on, other apps or, whatnot to get your work done. So anyhow, you saw I plugged each one in. I plugged in 1, 2, 3, 4, 5 different numbers to the function to calculate the output. I plugged in 5 different inputs to calculate 5 different outputs. Plugged in -2, -1, 0, 1, and 2, right? And all the outputs are here, and I can graph this now, you guys. Let's see how this turns out. So I used -2, -1, 0, 1, and 2. When I plugged in let me fix these outputs a little bit here. Let me go. I guess I'll just go 1, 2, 3 since it doesn't necessarily go that high initially. So at -2, 2.56, guys. -2 and up 2.5. You can't get that perfect, but again, -2 and 2.56. So I'm going approximately 2.5 spaces up because 2.5 is 2.5. That's pretty close. Then -1 and 1.6. So that's left 1 and up 1.6 spaces. Again, it's 1.5 would be here, so I tried to go a little more than 1.5 because it's 1.6. Then I have 0, 1. Well, 0, 1 is here, right? Next I have 1 and 0.625. Well, 1 right and a little more than half a space up. And then 2 and 0.39, so 2 right, and then a little less than half a space up. And at that point, it does start to look exponential. Definitely doesn't look like a straight line. It looks like a curve. So, you could just end by drawing this in here. It'll definitely start to flatten out, and it'll never reach 0. This is not a great... It's not a great drawing because I missed this dot here, but either way, it doesn't matter as long as you had these numbers right. You'll be doing this in Alex tomorrow, so Alex could accurately graph these points for you. If doing it by hand, you kind of gotta estimate a little, but Alex will just do it perfect. So there's number 1. I'll let you be for a moment on number 2, see if you have any questions. And as I'm kind of waiting for you to see if you have questions, I'm going to go into Desmos and remind you that you can use Desmos to write on my presentation screen. You can use Desmos to graph these, like y or g of x equals 5/8 to the x power. 5/8. See how this works. There it is, 5/8 to the x power. In fact, this probably should have had some parentheses around it. Oops. Anyhow, so y equals 5/8 to the x power, or even if you put g of x exactly how it's written, it's still going to do the same thing. It'll graph it for you. And then you can see it's 0, 1 here. If you click at -1, you can see it's 1.6. If you click over at -2, it's like I can't seem to get it exactly on -2, but either way, -2 and 2.56, right? That's close enough. Over here at +1, whoops, 0.625 as stated earlier. Over here at +2, 0.39, 0.391. Anyhow, guys, I'm just showing you that you can use Desmos. You can even, remember, you could go to the plus sign and insert a table, and you could see, right, you could type a function in like y1 approximately equal to 5/8 to the x1 power, and then you should be able to plug in numbers here like -2, and hey, why is it not telling me what the output is? I know we can do this. I know we can definitely have it give us these outputs, but I'm not sure what I'm doing wrong here. Either way, you can definitely come in and still graph it. Number 2. Number 2 is f of x equals 2 to the -2 to the x power. Let me go back to it. Yeah, guys, that -2 is making the base a negative is going to make it flip down over the x-axis. So one thing I can advise you on this one is you might want to think of it like this, where you raise, because basically you have to, I'm on my dot cam now, but basically you have to, sorry, I'm losing my train of thought here, guys. You have to use the negative sign only once, okay? So as long as you only use the negative sign once, you will get your outputs to be negative numbers, which is what is accurate. And anyhow, if your outputs are all negative numbers, you would be able to see how that eventually does flip the equation over the x-axis. -2 to the x power, see that? See how it flips down over the x-axis? So That's, again, for number 2, but I'm going to let you be on that one. Skip ahead to number 3. Number 3 gives me this table. Well, you might want to leave some space for number 2, actually, but kind of already wrote it, so anyhow. Number 3 gives me a table, tells me it's exponential, asks me to write the equation. So what do we have? Negative 1, 0, 1, 2, negative 1, 0, 1, 2. Outputs 5, 10, 20, 40. 5, 10, 20, 40. Guys, make sure you read the problems, because this problem tells me right off the bat. Below is a table for an exponential function. Use the table to write the equation. Well, guys, once it tells me it's exponential, I know for a fact I'm using y equals a times b to the x power. Again, it tells me it's exponential, so I know it's y equals a times b to the x power. Once it tells me that, remember your initial value is a. Sorry, excuse me. And then b is your rate of change, right? It's multiplicative. What is being multiplied by? Right, what's the multiplier? Remember, your initial value you find where x is 0, your output is 10, your initial value here is 10, and your rate of change, guys, is, well, if you check this out, it's not too hard to figure out. It's 5 times 2. It's 10. 10 times 2 is 20. 20 times 2 is 40. So the multiplier, the multiplicative rate of change is 2. Well, now that you have your rate of change in your initial value, you can write the equation. Y equals 10 times 2 to the x power. Okay, so it's what we just finished looking at in the last unit. I'll pause for a minute and let you take a look at number 4. So number 5, you make sure you go back and complete numbers 2 and 4. I'm going to plug ahead here to number 5. Number 5 is the graph of an exponential function is shown in the figure below. The horizontal asymptote is shown as a dashed line. Find the domain and range. Okay, so domain and range. Remember, the domain of these functions is referring to the x values, aka how far right and how far left will this function go. And anyhow, it ends up being all real numbers, guys. This function will never stop moving to the right. Yes, it is going up, but it is also going right. And it'll never stop moving left. It will never actually reach this asymptote. It'll never get down to -3, but it'll keep moving left anyways. Even though it doesn't get lower, it keeps moving left all the way to infinity, or should I say negative infinity, and all the way right to positive infinity. So your domain is all real numbers. It's aka from negative infinity to positive infinity. It's all real numbers. Your range, however, is different, right? Your range is how low this graph will go and how high it'll go, aka your y values, all possible y values. Well, if you remember from the unit, this curve never gets to -3, nor does it get lower than -3. But it always exists above -3, and it actually keeps going up forever to infinity. So again, it never actually reaches the asymptote, never actually gets to -3. It only exists above -3. So aka your range is that y has to be greater than -3. All the possible y values are all the y values that are greater than -3. At -3, the graph never touches it. Anything lower than -3, you can see the graph does not exist in those points. So again, your domain is all real numbers, but your range is just that y has to be greater than -3. As long as y is greater than -3, it'll show up on this graph. So I'll let you be for number 6. I'll wait a sec, but then I'll chime in on number 7, and I'll kind of let it be at that point, see if any questions pop up. So I wrote down the functions for number 7. F of x is -5x minus 3, g of x is 2x squared minus 3x, and they want me to find f of 7. So make sure for f of 7 you use the function f. F of 7 equals -5 times 7 minus 3. Okay, again, make sure if it's asking you for f of 7 or f of a number, you use the function f. So that'll be, let's see, negative 5 times 7 is negative 35. And negative 35 minus 3 is negative 38. So 7 goes in, negative 38 comes out. Again, when the input is negative 7 for this function, the output is, excuse me, when the input is 7, the output's negative 38. And then over here, right, let me define g of negative 4. If you're looking at the problem, you can see it's asking you for g of negative 4. So you better make sure you plug into the function g, plug in a negative 4, so 2 times negative 4 squared minus 3 times negative 4. Okay, excuse me. And then g of negative 4. Well, guys, negative 4 squared, that's negative 4 times negative 4, which is positive 16. And then minus 3 times negative 4, that's actually like a negative number times a negative number, so it's going to be a plus 12. Okay, 2 times 16 is 32, and then 32 plus 12 is 44. So again, that was a function f and a function g. Excuse me. And they asked me to find f of 7. That was here, negative 38, and g of negative 4. That was here, 44. So let me know if you have any questions, people.